Hello guys, welcome to my YouTube channel. This is my first video. In this video, I will be manipulating a putty executable file and opening a dialog box. So this process is known as PE code injection or portable executable code injection. So for this, we will be requiring three tools. First, OllyDBG, XV832, and Lord PE. And we have our putty right here. Just a second. So this is our putty file. You can do the same task with any executable file on your PC. For demonstration purposes, I'm using putty, and on Windows XP, as you can see the background. So it is a 32-bit computer. So that's how a normal putty file opens with some basic functionalities. So what we will do first, we will try to look what a basic putty file looks like. So I am opening OllyDBG. So let's open our putty file. Yeah. So as you can clearly see, this section, just follow my cursor. So this section is known as the stack. So it shows what values are there in the stack. This section is the registers. So it shows you the value of registers: EX, ECX, EDX, EVX, ESP. So these are the basic registers used in the assembly operations. This is the base original code flow, the original assembly code for our putty, and this is the address hex dump. Yeah. So at this, as you can see in the register panel, this address is our module entry point. This address, if follow here, it will go to 004A1086. So this is our original address. So let's copy few bytes. I'm copying 3 bytes. Copy to clipboard, a notepad. Let's paste them. So we will be needing this original address in later stages. So let's open memory map and see what all sections are there in a normal putty file. So this is known as memory map. As you can clearly see, there are many sections: a text section, R data, resources, relocations. So all these sections are with privileges of read, write, and execute. So what we will do, we will add a new section and we will create a code cave. So first, let's see what's a code cave. So what is happening? Uh, we will be hijacking the entry point. That's when you open a executable. That's where your pointer is starting from. So in basic terms, uh, when you open any executable, the first instruction your program runs is instruction which is present at the entry point address. So our task is to hijack that entry point or redirect that to our cave code address, which will be our new section. We will name it anything, XYZ or anything. So in this cave code address, I will be writing malicious instructions. In our cases, I will be writing a normal OK dialog box. Then we will redirect the code flow to the normal functionality so that putty opens normally. So let's perform this task. So first we will open Lord P. So Lord P is uh, as you can see, is a P editor tool. You can edit any uh, executable file, you can add new sections. So let's edit our putty file, open it. You can see there are a bunch of informations. So our entry point is at this. So let's go to section, uh, right click, add section header. So a new section has been added. Again, right click on that, edit section header. So we will name it anything. Hello. I am giving it a virtual size of 1000 bytes, raw size of 1000 bytes. Okay. So clearly you can see a new section has been added, namely hello. Save the file. Now we will open putty again in OllyDbg and confirm if whether our section has been reflected back in the Ollie or not. Go to memory map section. Yeah, so a new section has been added, which is at the address of 0051A0000. So in reality, this is our code cave address. So we will save it. Code cave address. This so we will be hijacking this address, redirecting it to our code cave address, performing some malicious task. In this case, not so malicious, and then redirecting it to this address. Yeah. So first, let's open Ollie. Putty exe. So it is opening normally, right? What we have to do, we have to add some, as we have added 1000 bytes in the putty, but uh, we have to edit the uh, we have to add 1000 bytes via XVI tool. It is a hex editor tool. We have to, in reality, we have to add uh, the bytes, because lord p is cannot add bytes. It just changes the heading sections of that. So let's open putty. We'll scroll down till the end. We are here. You can clearly see. Go to edit section. Just follow my cursor. Insert string 1000 decimal, and we will adding 00. Okay. So you can clearly see we have added 1000 bytes. Control S. So yeah, file sharing violation because my putty is open in the Ollie. So let's turn it off. Now Control S. So now 1000 bytes has been officially added. I will show you where this part is important, because I have now I have added only 1000 bytes. If I add 10,000 or more bytes, uh, the putty will, or any executable will crash, because Windows will not be able to verify the address, because on paper, or we can say on the section headers, the address is increased by 1000, but in reality the address has not been increased. So that's why performing this task by any hex editor tool is important. In 64-bit architecture, we use CFF Explorer or X64DBG or any other tool. Yeah, so let's open Ollie. Opening up putty. So let's change it to jump. to our code cave address, and our code cave address is 0051A 000. So let's save it. I'll rename it to hello. I'll restart the debugger, open my new file, putty hello. Yeah. So as you can see, the initial entry point has been changed, and now whenever I try to open the program, it will jump to my code cave address. Let's press F7. So here we come. So this is my code cave. This is my 1000 bytes which I added. So you can clearly see this is the stuff. So you can count it from this to this, the starting point. I have added only 1000 bytes, and all these instruction you are seeing is just garbage value. I'll select some of them, and I will fill it with nops. Nops is known as no operations. Now I have to add our Windows dialog box. So before doing that, I will save the register values by performing push AD, push FD. Now for the official Windows box, we will go here. So this is the official MessageBoxA format, the syntax from the official Microsoft site. As you can see, uh, in the middle, there are text and caption. So I'll show you how MessageBoxA looks like. So that's how a message box looks like. It's a normal message box with only one function, that is OK. You can only click the OK button. Uh, at the heading section, we have our caption, and in the middle we have the text. So yeah, you can refer any kind of syntax from the official Microsoft website. Before doing that, I have to add my strings somewhere because I cannot write like this. For example, first I'll write push 0 by following the syntax, and now in the middle I have to write my caption and my text. So I cannot write, or I cannot push straight away the strings push hello. So this is not allowed because you can only push the address, push with some address. So for now I'll push some random value. You can push anything and push 0. Now I'll select some bytes. Let's go to 00518 029. You can go anywhere you want. So I am selecting these many bytes. Go to binary and edit. So I'll edit the ASCII values to hello. Click OK. So in hex code, this is my hello is converted to 68656C 6C6F. Okay. So copy this address, or it's basic 029. So what I'll do, push 0051A029, and then again push 0 and pop FD, pop AD. So what I did, I followed the basic message box syntax: push 0 in the starting, push 0 in the end. So what, let's refer to the again. So push the last push 0 is for the type of message box I want. So in the end, when you write push 0, it is for a simple message box with OK button. In starting, we have to push 0 for uh, the H window option, the header window, you can say. At last, I pop the registers, because when we are performing these tasks, instructions are using registers, and we have to restore them. So it is a better approach for first pushing the AD and FD register, and at last popping them. So I'll select these many bytes and save it. So for saving, go to the copy to executable, click selection, a new window will open like this. Click right button and save the file. So I'll save the file in the same file, putty underscore hello. Yes. So let's restart. So I debugged the putty. Let's try to run our file. So I'll go to the desktop and simply open our putty. This is my file putty hello. Oops, it's crashing. Let's figure it out. So I will try to add uh, the errors in the video, because uh, uh, solving errors myself will not gain anything to my viewers, because debugging the error is the most crucial part in cybersecurity, especially in reverse engineering and malware analysis, because that is the part which is most exhausting, and it just uh, user have many people just give up in between. So let's try to debug where is the fault. Oh, it's simple. See, I added the syntax for the message box, but I never called the message box. So in any executable file, there are imports known as kernel32dll. So that kernel32dll contains the uh, message box code. So I can straight away call that. So I'll write call message. It is uh, message box A. So it is user32 dot message box A. Then again I'll pop fd pop ad. Yeah, cancel. Okay, I disturb some bytes. So I will have to change it. Hello, this. So let's edit our binary again quickly. Hello. It is at address 021. So I'll simply add it 021 again. Yeah, and save the file. Copy to executable. Selection. Right click. Save file. Putty hello. Save. Yes, overwrite. So I'll again debug. Let's run our file. Press F7. Again F7. So when I press F7, for curiosity, also look at the registers and stack how these changes, right? Because in future when we will be doing more advanced code, we have to look for ESP and EBP value, and we have to manipulate that, and we have to have the knowledge, because these are the things on which our code really relies, because register and stack are really crucial in these kind of things. So F7, F7, and I press F9. So let's look. Oh, so here, there we go. That's our message box. So we are seeing garbage value. So we will try to resolve that. So I'll show you when I click putty hello and see. Now here's the thing. Uh, First we will clear the garbage value, but before that I want to show you we successfully hijacked the entry point. So when I'm clicking putty, my message box is being opened. But when I click OK, so that's when the code crashes because it does not know where to go because we have garbage value after our calling the message box function. There are so many knobs operation. After performing that, the code simply does not know what to perform because these values are just garbage. So we have to redirect our code flow execution back to the initial entry point. So that's how we are going to achieve our task. So first resolve the uh, garbage value error. So let's select some more value. We will edit. This is my first video. Okay, and we are again at 2:1. So let's save that. Uh, we are seeing garbage value. Uh, it is not a very big type of error because it's just random errors which sometimes only gives. Okay, and we will again start the debugger. So let's see. Okay, again the error is coming. So let's debug the string error. So as you can see, we are clearly hijacking the entry point. Click F7. So as we are inside our code cave address and at 0 to 1, here's my string. So let's again select some bytes and write something else. Binary edit. So as you can see, this is my first video. So okay, dot space. Okay, let's run it. Okay, okay, again the error is coming. So again start a debugger. Click F7. Jump to our exact address. Select some more bytes. Let's select some more bytes. Let's fill them in knobs. Go to 0 to 1. 0 to 1. Yeah, here we go. No. Oh, okay, so I don't want to set a breakpoint at this. We'll select more bytes, add it. I'll write my video. Okay, now if we run it again, the error is there. So as you can see, it is giving some random error, user trust RSS certification. So all these things are just garbage value, and any executable or any file uh, just mix bunch of code and spit it out in the form of garbage. So all these values are coming from inside the system only. If we open XVI32, we can see all these garbage value being stored in a particular section. So what we will do, we will select bytes of our string. Let's select these many bytes, convert them to nops, and again write our string. So this is my first video. Now, as you can see, there are random ASCII character E. So I'll simply write, or I'll change the hex from here. So 000. I'll convert all of them to 000. Click OK, and let's run it again. Yes, as you can see, all the garbage strings have gone now. So just by adding a normal 00 at the end, we were able to solve the garbage problem. So let's save it, save the changes, uh, copy to executable, save file. Yes. So now we have a clear process, and if we click, and a clear message box is being popped, and when I click OK, the program will crash. So to give our pointer the code flow execution back, it is very simple. We have to go to our notepad, and at the end, sorry, we'll just go to, we have to start the debugger again. Click F7. At the end of this, what we will do, first we will call this function, because this function is opening the configuration window of the putty. At entry point, when this run, that's how we are able to see the putty configuration window. For example, when I open this, so this window is being popped because of this function, that is call putty dot 004a12 e1. So whatever is being called at this address is the reason we are able to see this window. So our main task is to uh, redirect the code flow execution. So I'll copy that address, go to my putty. So as you can see, uh, the ASCII has this ASCII has been there. So at the end of my pop AD code, I'll click spacebar and Control V, and I'll remove putty dot. So I'm simply calling that address, which is responsible for showing the putty configuration window. And now I have to jump to my second address, that is this address. So as we are clearly able to see what we have achieved, uh, we redirect the code flow from here. We go we went to our code cave, and then we are returning the code flow execution back to here. Return. So I'll jump the putty to this address, 004a10, this address. So right jump, I'll copy that address, assembly, and okay. So let's simply save it, and hopefully we are able to uh, perform this task. Save the file to putty. Let's save it to another file. One. Go to our desktop. Then here we go. Let's click on it. So as you are able to see the difference, this file putty underscore hello is my normal file where I did not return the code for execution, and that's why the program is crashing. When I click OK, and when I return it to the initial address, the program is working perfectly fine. When I click OK, the putty configuration window opens. Now the thing is that uh, we can in this video I'm opening a normal message box, but someone can open a reverse shell. When you open the putty, it will pop a reverse shell in the background, and the putty configuration window will simply open. For example, if we so in our next video, we will be uh, I will be showing you how you can pop a reverse shell and get connection back to your Kali machine. For example, I have this file, putty file. So what happens is when I click this putty file, it opens normally, but in background on my Kali machine, I got a reverse shell. So it is listening, and there we go. So this is my reverse shell to my Windows machine. So in order to show the normal code flow execution, I'll start again, cancel. So when I click on this, the putty is opening normally, but after a few seconds, I'll get a reversal here. So what reversal basically is, I get a command shell execution of this Windows machine back to my Kali machine. So I can literally see anything, and I actually have the whole access to the Windows machine now. I can see the putty file, putty hello underscore one. All these files I am able to see. So in next video, we will be seeing how to perform this task. Thank you.